This question it says a student investigates 4 different radioactive isotopes. The student places a detector. Let's take note of this word detector. The background count rate is 36 counts per minute throughout the investigation. And this table shows the detector readings at the start. That is when time is 0 and after 8 hours. Which isotope has a half-life of 4 hours? So basically what we are trying to do is to check for a given count rate at the start, what will be the count rate after 8 hours. So when you check for each of them, the one that agrees or the one that tallies is your correct answer. But before we do that, we need to be familiar with some basic relation. So the first relation, I will say MC, so which is the measured count rate. MC, measured count rate, is equal to the sample count rate. So I'll call it SC plus the background count rate. Background count rate. Okay, so this is the first relation that I needed to be aware of. So the measured count rate is basically what is being recorded on the detector. Because when the detector is recording, obviously, whatever is recording, the background is also part. So the measured count rate should be noted. So this is the relation. And also, 2 more relations I want you to be aware of. So I will say A is equal to A naught over 2 raised to the power n, where A is the sample, that is the count rate for the sample at a given time. So I would say the sample's count rate at a given point in time. So that is what the A is representing. And the A naught will be the initial sample count rate. The initial sample count rate. So I emphasize this formula, this A and the A naught you are seeing here, they are for the sample count rate formulas. So A is the sample count rate at a given point in time, and A naught is the initial sample count rate over 2 raised to the power n. This n is the number of half-lives. So the next formula that I need you to be aware of is the half-life formula. So T half. So T half is representing half-life. That's the time taken for half of the radioactive elements to decay. So T half is equal to the total number of time, the specific time, which is T. That's the total time of the question, whatever question they are talking about, over n. So these are the formulas. Please note that these formulas that are written here, these 2 formulas, are only used on the sample count rate. So when you are given a question, make sure you're able to digest to know which one is sample count rate before you can use these formulas on it. That being said, let's go straight to the question. So in this case, so now let's consider option A. So option A, it says the count rate at the start. Remember, what is given here will be the measured count rate. The options that you see, the 4 options that you have here, they are the measured count rate. So for option A, the first we are going to do, so for option A, the first thing we have to do, let's get the sample's count rate from the measured count rate that was given in the question. So the sample count rate for option A will be equal to 150 minus 36, which will give us 114. Okay, so therefore the sample count rate after these 8 hours, so let me say A will be equal to the initial sample count rate for option A. From this, it will be 114 divided by, remember, we have subtracted the background count rate from the measured count rate, and that gives us a sample count rate of 114. So this 114 is the initial sample count rate that we are talking about, option A, over 2 raised to the power the number of half-lives. So remember, the half-life is 4, and the time that we are considering now is 8 hours. So we can use the second formula to be able to determine the number of half-lives. So here, if I do n will be equal to t over half-life, t half-life. So let me do that again. So it will be t over t half-life. So my number of half-life will be 8 hours over the half-life, which is 4. So my n is equal to 2. So which means that in this case, our n will be 2. So which will give us 28.5. So which means that this 28.5 is the samples count rate after this 8 hours. But from what we want to know, we want to know the count rate, which is the measured count rate. So to find the measured count rate in this case, it will be 28.5 plus 36, which is the background count rate, which will give us 64.5. So obviously, you can see that after 8 hours, we are not getting 64. So option A is wrong. So now let's go to option B, the same procedure. So for option B, we need to find the samples count rate. So samples count rate, which will be 212 minus 212 minus the 36. 212 minus 36, which will give us 176. So our sample count rate, our samples count rate in this case will be the initial sample count rate, which will be 176 in this case, divided by 2 raised to the power the number of half-lives, which will be here. So if I compute this, I will get 44. So which means to get the measured count rate, I must add the background count rate, which is 36, to the 44. Okay, so that gave us 80. So you can see that the measured count rate for option B is supposed to be 80, and it is not 80, so option B is also wrong. So we go to option C and repeat the same. You go to option C to repeat the same thing. So for option C, I get the samples count rate. Which will be equal to 260 minus the background count rate, which is 36. This will give us 224. So which means that to get the sample count rate after this 8 hours, so A will be equal to this 224 over 2 raised to the power 2. This will give us 56. So now if I want to get the measured count rate for this case, it will be this 56 I have plus my background count rate, which is still 36. So if I compute that, I'm getting 92. So you can see for option C, the measured count rate after the 8 hours, I'm getting 92, and this is 92. So which means that option C is correct. So my answer is C. So you can double, if you want to double check, you can double check for option D as well. So for option D, our sample count rate for option D, our samples count rate will be equal to 356 minus 36, which will give us 320. So our sample scan rate after the 8 hours, our A will be equal to this 320 over 2 raised to the power, the number of half-lives, which is still 2, equal to, this will give us 80. So therefore, the measured count rate after these 8 hours will be equal to 80 plus the 36. And this will be equal to 116. So which obviously also is incorrect. So our answer is C.